Hi everyone, Professor Bob Young here. In this instructional video, we're going to discuss increasing, decreasing, and constant functions, and maybe even throw in a little domain and range as we go along. All right, so the definition for increasing, decreasing, and constant functions is as follows. It says, suppose that a function f is defined over an interval I, and you have some points here. If x1 and x2 are in the interval I, f increases on that interval whenever x sub 1 is less than x2 implies f of x1 is less than f of x2. And remember, another way to write that is y1 is less than y2. Part B says f decreases on the interval I whenever x1 is less than x2 implies that y1 is greater than y2, or f of x1 is greater than f of x2 in that functional notation. And the function is constant on the interval for every x1 and x2 if y1 equals y2 or f of x1 equals f of x2.
All right, now a lot of times students will get these definitions and they'll scratch their heads because the notation kind of confuses them. So I wanted to give you a pictorial on this real quick. Now notice the definition here. It says if f increases along this interval I here, whenever x1 is less than x2, so I just picked a few points here and I label them. Now notice my x1 value here is -2, and it certainly is less than this x value over here in the first quadrant of 5. And notice here, y1 or f of x1 is 1 is less than 4. So whenever you have an increasing part of a function, it's going to go in an upward motion from left to right. So notice here the x values, this x value is smaller than this one, implies that this y value is smaller than this one, always makes the curve go upward from left to right. Whereas if it decreases here, notice the x value I chose here in the second quadrant, x sub 1 is -3, is less than the x value to the right of it, 7. But in this case, notice the y here is larger than the y down here. So in other words, this y1 is 3, is greater than this y in the fourth quadrant, -4. So whenever that happens, the strict definition of a decreasing function along a curve just shows that it's going downward from left to right. Now think about making investments. Would you rather make an investment that goes upward here or downward here? And then the constant function, notice it doesn't really matter what the x values are. I put -2 here for x sub 1 and 4 here. Y will always be constant along this line. So note it doesn't matter for any x value you pick, the y's will always be the same. So what I want to go ahead and present next is how I like to look at this in a little bit different light, and I hope it helps you see increasing, decreasing, and constant functions.
Now, what I like to tell my students, correlating with these rules, I always like to say increasing functions have a positive slope from left to right along the x-axis. So when I look at increasing, decreasing constant functions, I'm looking at the x-axis only from left to right, so I don't give a rat you know what about the y-axis. And always use parentheses to indicate increasing, decreasing constant functions, never brackets. We'll get to that as well. Decreasing functions, if they follow those rules on the previous slide, have a negative slope from left to right. And a constant function, I always tell my nursing students, you never want to be on a heart monitor and have a constant function. This would be a zero slope, or you get the idea, no heartbeat. All right, so we'll go ahead and look at some examples here on these next two graphs. And on the first graph here, it looks like we have a absolute value graph. Now we're going to learn in later sections, most absolute values begin at the origin here at 0, 0. So it looks like this one shifted 2 to the right and 3 up. So later on, and this will take note, I would say this function would be f of x equals the absolute value of x minus 2, since there is a horizontal shift 2 to the right, and then plus 3, which would indicate a vertical shift 3 up. All right, but that's just a whole different topic. Now I'm going to come over here and talk about increasing, decreasing, and constant functions here. Now this one doesn't have any constant area, so I'm just putting increasing and decreasing there. Now notice here, if you look at this line going, it's going a positive slope. Now where at on x is it going positive? Well, it's increasing from 2 to infinity, okay? And always use parentheses on these. Now the calculus instructors will go crazy, and I've even seen in some of the notes that they'll put brackets here, but that's wrong, because at this point, until it actually starts moving upward, downward, or level, if it's constant, you don't exactly know at that point what's happening. So to indicate that, use parentheses. All right, it's decreasing coming in on x from left to right from negative infinity to 2. All right, so you can see here that the positive and negative slope angle I'm trying to get at. All right, now something else here, let's just throw this in. The domain of this function, and it's a function because it passes the vertical line test, and each different x corresponds to exactly one y. Now notice this thing goes off in both directions on x along this axis. So we could say the domain is negative infinity to infinity, and the range of this function, if you look at the y-axis here, would be 3 going upward towards infinity, and it would include 3. Okay, so on domain and range, you can put brackets if it includes that part of the graph, but on increasing, decreasing, constant, never here. All right, let's look at this next graph. Now this is a parabola that looks like it shifted 3 units to the left and down 1. So if I were going to write this, and this is getting to a later section here, you may want to come back and watch how I shifted these. You would have x plus 3, since it shifted left 3, quantity squared. So notice those horizontal shifts don't necessarily shift the direction you expect, and then the vertical shift goes minus 1 here. So that would be the equation I would anticipate for this graph. But if I'm going back here, let's go back, increasing and decreasing. And again, this part right here has a positive slope, is going to be increasing. Now where is this at on x? It's coming in from negative infinity and stopping at negative 3. Again, always parentheses on these. It's decreasing along x from left to right from negative 3 to infinity. Okay, and I just wanted to throw in here the domain and range because, again, students get that mixed up. The domain of this function, and again it's a function, is negative infinity to infinity, as this thing along x will keep expanding and opening wider and wider along here. Sorry, that's a bad semicolon up there. And the range, the y part, starts at negative, it comes up from negative infinity on y and stops at negative 1. So this would have a bracket on negative 1 if you're talking domain and range. All right, in our next few graphs here, let's go ahead and look at increasing, decreasing, and constant functions here. This is the first time we have all three, so I'll put IDC. And in my lecture classes, sometimes students will go, what does this mean when I put IDC? And they'll go, I don't care. I'll say, no, stop it. Increasing, decreasing, constant. So,
All right, on this first graph over here, we're going to look at this function. Now there's a hole right here at x is negative 1. So we're going to go ahead and look at increasing, decreasing, and constant functions here on this one. So notice from left to right, this thing is increasing from negative 3 to negative 1 along the x-axis, again disregarding y. It's going to be constant along x from -1, it looks like, to 5. So we'll go ahead and put that in there. And it's decreasing from 5 to 8. Now again, when you're saying increasing, decreasing constant functions, always use parentheses there. And when we talk about the domain of this function, we're going to look at x from -3 to 8. Now remember, there's a hole here at -1 on x. That's an open circle, a bad one at that point, but sorry. So we'll say the domain goes from -3 to -1. Now notice it can include -3. It's part of the graph. You can put a point there if you want to. But on the -1 does not include. And then we're going to use the union symbol here to put -1 to 8. All right, so it can't be -1, but it does happen along x all the way to 8 and stops there. So we'll put a bracket. So just to show you the difference between parentheses and brackets on these. All right, range, the y values on this function. Now we're looking along the y-axis here. So this thing starts on y at 0. And if you think about these points here, if you want to, you could put the ordered pair -3, 0 and 8, 0, which would certainly be x-intercepts. But do you see on y, it goes from 0 to 2 and includes all of those values between there. And notice here, even though it has the open circle on x here, it does have y values all along here at 2 and everything going from 0 to that.
Okay, for the next graph, I tried to do something similar. I'm going to put increasing, decreasing, and constant. Now notice this one is increasing where here? Well, it looks like a negative slope coming all the way down. It looks like a negative. I don't see it increasing anywhere, Young. All right, so be careful on this one. So it looks like it's decreasing on x, this whole interval here, from -infinity to -4. So it may not have all three or even two of the three sometimes. It may just have a couple. Now you don't want to put union on this one because it's going to violate that rule that we talked about earlier. It does also decrease, so you want to use a comma here and not the union symbol. It's going to decrease from -1 to infinity on x. So this thing is decreasing a lot in different circumstances here. Okay. Now the reason for that, there is no union symbol there. It goes back to that definition for decreasing functions. Go back a few slides and look at that, and you'll see why the union symbol doesn't go there. And this is constant from on x -4 to -1. All right, so that would cover the increasing, decreasing constant along this. Now, domain and range on this one would be -infinity to infinity, because on x this thing keeps going both directions endlessly except at -4 here. So if we wanted to look at the domain, and again these open and closed circles can drive students crazy, we're going to say its domain is -infinity to -4. Okay, since there's an open circle there, and then union -4 to infinity. Okay, so along x, now you just have to look at this axis. Don't worry about y, just worry about x, especially on increasing, decreasing constant as well. But on domain here, that's why you have parentheses on the -4. Now the range here on y, the y values go downward forever, upward forever, and notice here at -2, it does cover y values at -2. So even with the open circle there, the range is all real numbers. All right, one more example here on this graph. We're going to look at where this is increasing, decreasing, and constant. Now this part right here looks like it's decreasing along the x-axis from left to right. So I'm going to put decreases from where on x coming in here, from -infinity to 1, always using parentheses. It looks like it's increasing along this. This would be positive slope going from left to right on x here. So I hope I'm giving you enough examples to set this thing straight here. So this would be from 1, 2, 3. It would increase along this little path here, and then it would be constant here on x from 3, and it looks like it's going to flat line all the way on x to infinity. So that would be the increasing, decreasing constant for those three. Now, Young, how do you use this in real life? I mean, that is the student's overwhelming question. So let's look at a graph here. It says this graph shows the relationship between the number of gallons G of T of water in a small swimming pool and the time in hours T. All right, so not everything in math is always X and Y. In this case, the X-axis is talking about time T in hours, and Y is talking about number of gallons. It says answer the following questions using the graph information here. All right, it says A, what is the maximum number of gallons of water in the pool, and when is the maximum water level first reached? All right, so if we kind of look here, the maximum water, I would say it would be up here. All right, and it would probably be first reached about 25 hours at 3,000 gallons. Okay, let's see if we're right here. All right, so the max range value is 3,000 and the max number of gallons 3,000, so we're looking good there. It says for how long is the water level increasing? So I would say that would be probably from time 0 to 25 hours. It looks like it's decreasing from 50 to 75, this interval here. So that would be what, about 25 hours, and it would be constant from 25 to 50 hours here and from 75 to 100 hours there. So you can see that you might interpret graphs of this kind in the real world. And there's the solution we were talking about. Water levels increasing from 0 to 25 hours, decreasing 75 minus 50 from here, 25 hours, and as we said, constant for the 50-hour period here and here. All right, last part of this graph, and you may be asked to be interpreting these things in different ways. How many gallons of water are in the pool after 90 hours? Well, it would be in this interval right here, I would say. So I would have to say, looking across, about 2,000 gallons, and verified there. So next, it wants to describe a series of events that could account for the water level changes shown in the graph. If you own a swimming pool and you kind of see this upward pattern, level, downward, level, you may know some things here, just common sense. But the pool is empty at the beginning, then filled to the level of 3,000 gallons the first 25 hours, and the water level then remains the same. At 50 hours, the pool starts to be drained over 25 hours to 2,000 gallons and remains there for 25 hours. And so you can use this to interpret a lot of things. I mean, I'm sure you're a pool person and you know chlorine levels, other things have to deal with it, rainfall, and so forth. So I just wanted to throw something in there to show you that yes, this can be used in other things outside of the classroom. So that's it for this video. We will see you at the next lesson.